Welcome to Mathletes. I'm Gori, and today we'll be tackling networks and finding the minimum spanning tree. We'll be looking at every exam question ever asked in HSC Standard 1 over the last 5 years. So grab a pen and let's get started.
Okay, so this is HSC Maths Standard 1, networks, edges, vertices, degrees, and finding the shortest path. So first question, consider the network diagram. Which vertex has degree 4? So the vertexes are simply the dots, and the degrees are the number of connections that each dot has, or the number of lines that it has. So pretty easily, what we can see is that when it comes to vertex B, it has 1, 2, 3, 4 lines connecting to it. So we can say vertex B has 4 degrees or 4 connections. And we can see the answer is indeed B. All right, question 15. A network of towns and the distances between them in kilometers is shown. What is the shortest path from T to H? Okay, so just checking out T and H on our diagram, we want to choose the most direct path. It's probably going to be the shortest one. So if we pick 30, and then we have a decision with Y, do we want to go for 15 or 38? We want to pick 15 because it's the smaller number and we want the shortest path. And then at W, we have another choice to make, and we want to go for 20 because it's both the smaller number and it's directly connecting us to H. So our answer would be T, Y, W, H. And we can add those numbers up. 30 plus 15 plus 20 gives us 5 plus 1 is 6. 65 kilometers. And we always want to do a quick check just to make sure that there isn't another sneaky way that might be shorter. So we want to check if we did go via J, that would be a smaller number than 30, but then getting basically to the same place, to W, we would have to go 32 plus 25, which is 57. And when you add 57 to 23, that's obviously going to be bigger than 65. So we know we've got the shortest path with TYWH. A truck driver needs to travel from Y to G, but knows that the road from C to G is closed. So what is the length of the shortest path the truck driver can take from Y to G after the road closure? Okay, so we know that C to G is closed, so we'll get rid of that path. Again, we want to select the most direct path. That would be YWCMG, right? Let's add that up. So we get 15, 25, 25, and 25. Okay, so it's 10, 20, 2, 4, 6, 8, plus 1 is 9. So we've got 90. That's our most direct path, the most obvious path. But because this is the shortest path, there might be another way that could be even quicker. So when we get to W, that's a pretty obvious choice because 15 is much smaller than 30 or 38. But when we get to W, we could actually choose to go this way instead. We could go WH and then HM and then MG. So adding up those numbers, let's see if we actually get a shorter path. So that would be 15 plus 20 plus 29 plus 25. 5 plus 5 is 10 plus 9 is 19. 2, 4, 6 8. And indeed, it is one shorter than what appeared to be the most direct route via C. So the shortest path, it's going to be Y, W, H, M, G. And what is the length of the shortest path? It's going to be 89 kilometers. All right, let's check our answer. So we should get 65 kilometers for A and TYWH and 89 kilometers for G. All right, question 15. The table shows some of the flight distances rounded to the nearest 10 kilometers between various Australian cities. Use the information in the table to complete the network diagram where the edges are labeled with distances. Okay, so let's fill it in. Adelaide to Hobart is going to be 1170. Perth to Adelaide is 2120. Let's cross them out when we put them on the diagram. Brisbane to Darwin is going to be 2850. Sydney to Brisbane is 750. Darwin to Brisbane, 2850, which we've already got. And Darwin to Perth, 2650, we've already got that too. Sydney to Darwin, 3150. We don't have that, so let's add it in. 3150. Okay, Adelaide to Hobart is 1170. Already got it. Sydney to Hobart is 1040. We don't have that. Let's add it in. 1040. And we look pretty much done. Perth to Adelaide, already got it. Darwin to Perth, already got it. Sydney to Perth. Ooh, we don't have that. So Sydney to Perth is 3270. All right. And then Sydney Brisbane, got it. Sydney Darwin, got it. Sydney Hobart, got it. And Sydney Perth, we have it. All right, that's it. Masa wants to travel from Hobart to Darwin. She wants to change planes only once. Using the diagram, calculate how many kilometers she will travel by plane. All right, so pretty obvious, but if you're at Hobart, you've only got two choices. You can either go A to Adelaide or you can go to Sydney. If you go to Adelaide, the problem is that is one change of plane. And then we're trying to get to Darwin. She's going to have to change planes twice. So a second time at Perth. So we cannot go via Adelaide. We have to go, therefore, via Sydney. And if she's going via Sydney, again, to get to Darwin, just one change of plane, she'll get there. So that's the only possible solution. So it's going to be HSD. And the number of kilometers, it's going to be 1040 plus 3150. So adding that up, we get 4190 kilometers. And that's it. Excellent. A network of running tracks connects the points A, B, C, D, E, F, G, H as shown. The number on each edge represents the time in minutes that a typical runner should take to run along each track. Which path could a typical runner take to run from point A to point D in the shortest time? So another shortest time question. Unfortunately, it's just guess and check really is our method. So we can see that the most direct path to get from A to D, it would be, in my eyes, going this way, right? And that's pretty obvious. It's 5 plus 5 plus 5, which is 15, right? That's the path to beat, but I can see that there is a smaller number here. If instead we go AB and then BF, that way we can take off that 5 and instead go 4. So 3 plus 1 is 4. And then go 5, 5 again. And so then that's going to give us 14 instead of 15. So therefore, that would be the shortest path rather than the first path, which looked like the most direct route, but actually took a minute longer. So the shortest path, it's going to be AB, F, G, D, and it's going to be 14 minutes. Let's check our answer. A, B, F, G, D. A network diagram is shown. What is the number of edges in this network? Okay, so edges, just another word for the lines or connections in a network diagram. So we just need to count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer is 10, D. The answer indeed is 10D. All right, question 1. A network diagram is shown. How many vertices are in this network? So vertices are just another name for the dots in the network. So let's count them up. 1, 2, 3, 4, 5, 6. Easy money. 1B. The answer is indeed B. All right. Question 3. Consider the network diagram. What is the sum of the degrees of all the vertices in this network? Okay, so this is a bit trickier. So the degrees for each vertices is a way of saying the number of lines that are connecting to it. So A, for example, has 1, 2, 3, 4 lines connecting to it. So there's 4 degrees. For vertice A, for vertice B, it's 3. For C, it's 1, 2, 3, 4. For D, it's 2. And for E, it's 3. So we're simply adding up all of these numbers. 4 plus 2 is 6, plus 4 is 10, plus 3 is 16. So there you have it. Our final answer is D, 16. And indeed, the answer is 3D, 16. And that's all. Thank you very much.